you today is also going to help reinforce some of the things that are being asked in the first 5. So by the end of class today, you will feel a lot more comfortable with this. Helium-3. When we write, there's a way we can write a symbol that's very short. Right? We can also draw the structure, but in this case, we're looking for the I'm asking for the symbol, not the structure. What does the symbol look like, or what do we start with if we're going to write the symbol? HE. Why HE?
Because
that's how it's represented in the table, and it allows us to know the difference between helium and something else like hydrogen that might also start with an H. What will be the next part of this way that we've been writing the symbol, Ashley?
on the bottom you put the atomic number.
Okay. What is the atomic number in this case? Where would I find the atomic number if I couldn't remember?
It's 2.
The number of protons, it's 2, and in this case, not just in this case, but in any case, if I wanted to find the atomic number, if I wanted to find the proton number, where would I look? Where could I look every single time for it? The periodic table, and in the copy that we've been using in class, what part of the box is that in? The bottom
Left.
bottom left corner. Every time we're going to be able to find this number in the periodic table. The proton number or the atomic number. What else do I write to finish out this symbol?
On top of the H.
Why is now it's important for us to make sure that we put the numbers on the left side. Why is this that important? What are we reserving the top right for?
For if there's any extra neutrons in there.
No, not extra neutrons.
What was the question?
What if I am reserving this top corner up here?
Negative or positive?
For the
Negative and
yeah.
positive. Negative or positive is going to have to do with extra or not as many what?
Like
Electrons. Because every time I have helium, how many protons am I going to have? 2. And we always have the same number of protons for the same element. Okay, the second one is also helium, but what is going to be different about this symbol?
Mass number.
What's going to be different? Sure.
Was that it?
This is it for the first one. That's it. This is the symbol, but something I've noticed quite a few people doing is drawing the structure, and the structure would include a lot more, right? Structure would include the nucleus. We're going to practice with structure again today. Helium-3 has this symbol, but we also are looking at helium-4. What is going to be
the atomic number is 2 and the mass number is 4.
Okay. Why is the atomic number the same in both of them?
Helium.
Because it's helium. And just like we were just saying, it's always going to have the same atomic number. Why is the mass number or the nucleon number different? There's more of something, right? More of what? More neutrons. Right? That's what makes it different. What do we call if we have 2 forms of the same element? What do we call that?
Isotopes.
What?
And if you couldn't get that one, you could always look back at the questions. Actually, okay. Next one, nitrogen 13. Letter symbol for nitrogen?
That's when you have
N.
to do
And what numbers will we have on the left side here? 13 and 7. Last one, molybdenum.
on the bottom, on the top is 25.
95 on the top and 42 on the bottom.
This part's pretty easy, right? Now, nitrogen 13, when it's written this way, I can very quickly find out something else. What is the other information that I can very quickly? I know protons because I have them here, but what else can I find? Number of what? I could find number of electrons because it's neutral, there's no charge here. So the number of electrons will be the same as what?
The protons.
The protons. There's one more number I can also find here. Neutrons.
Yeah.
How would I find the number of neutrons?
Subtracting 95 from 42.
in this case, subtract 95 from 42, and I can see that how many neutrons would molybdenum have? 53. How many neutrons in this form of nitrogen?
7.
6. Okay. So very quickly we can find numbers of all of these subatomic particles that we've been working with, the neutrons, the protons, and the electrons. Okay, chlorine 37 and calcium 40 have something in common.
They're
Okay. How did you determine that? Okay, so if we start out by writing the symbol for chlorine and calcium, we'll pretty quickly see the reason that probably not very many people heard Vivica, but we'll get really quickly to what she was saying. Chlorine 37, how many protons in chlorine? What's the proton number? 17. Calcium 40, what is the proton number? 20. Well, they're both neutral, which would mean chlorine is going to have 17 electrons and calcium is 20 electrons. But what is the same? The other thing that we
the
can
same
find.
number of neutrons.
Okay, and how do we know?
Because you
Because we
subtract.
By subtracting. When we subtract here, we see that we have 20 neutrons and 20 neutrons. One of the things that's really interesting when we start to really look at the periodic table is sometimes elements that are quite different. As we learn more about chlorine and calcium, we're going to see that they're very different as far as their characteristics, their properties. But sometimes they'll have something similar, like the number of neutrons. One of the things that happened when the periodic table was being developed is some people wanted to base it on things like how many neutrons instead of how many protons or the atomic mass.
Yeah.
Different characteristics, and that would lead to some different information. Question, Kelsey? Oh, no, okay. Any questions about the first 5? Josh? No. So tomorrow, we do have a quiz in class. The activity we're going to do in class today is going to help get you ready for it. Also, you'll have a homework this afternoon that'll help you also be prepared for it. But it's these kinds of ideas of atomic structure, not just the symbols, but also the drawing of the structure, which we'll get some more practice with here.